Good evening, all. Today we are going to see the session about design and analysis of algorithm. In this design and analysis of algorithm, we are going that particular topic name is dynamic programming and greedy algorithm. So in this session, we are going to see about what is dynamic programming. And in this and how the dynamic programming can solve that particular program in problem in algorithm. So now we are going to see about what is dynamic programming. Um, in dynamic programming means every problem can have some solutions by using algorithms. So some kind of problems can have a large number of steps, and it's a very it's a very biggest problem to solve that particular problem by using algorithm. So in that case, we can't take that particular we can't give that particular problem solution in a single manner. So what we have to do is, by using dynamic programming, that particular problem can be solved by breaking them into overlapping subproblems, then storing that every single subproblems solutions can saved in that storing in that memory. By using that stored data, we can solve some more subproblems, and finally we can merge all those subproblems and give the solutions. This is the dynamic programming, and it can lead to efficient solutions. And what is the key characteristics of that particular dynamic programming is the two things. One is overlapping subproblems, which is already we have seen in this definition of the dynamic programming, which means nothing but it can break that particular problem into a subproblems, and each and every subproblems can give the some kind of solutions. Those solutions can merge, and finally we can get the exact final outcome of that particular problem. This is the overlapping subproblems. And what is the optimal substructure means it can give the optimal solution for that particular kind of problem, which means every subproblems can solved by efficient algorithm, which means if that particular subproblems can give the efficient solution, means the overall result can give the optimal solution to that particular problem. So this is the two characteristics in dynamic programming. One is nothing but overlapping subproblems, another one is optimal substructure. So what is the example of dynamic programming is nothing but Fibonacci sequence. In that case, what we have to do generally, Fibonacci series means we can add that particular number with preceding two numbers. So in that case, if we want to add two 0 and 1, means starting with 0 and 1, we have to add those things, means we have to add that two numbers with preceding of two numbers. That is the Fibonacci sequence. So here we have to define the Fibonacci sequence. If n is less than we have to make some conditions, if else conditions in that particular problem, that is if else condition. So if n is less than or equal to 1, that n value can be returned, or else that Fibonacci recursive can add the preceding two numbers for that particular number. So this is the Fibonacci sequence of the dynamic programming problem. And what are the other example by using dynamic programming to solve that problems means Knapsack problem can use the dynamic technique, and longest common subsequences also can use the dynamic programming, then that can give the efficient solution. And matrix chain multiplication can also use the dynamic programming. So these are all the examples which can also use the dynamic programming so that it can give the efficient result. So before we have seen already about Knapsack problem is one of the problem can solved by dynamic programming. In Knapsack problem is generally what is dynamic programming, it can break that particular problem into subproblem. So in that Knapsack problem, the same thing can happen. So that each and every subproblems can have some weight limit. Based on that weight means we can give some numeric values. Based on that weight we can make some efficient outcome of that particular problem. So in that case, knapsack is nothing but the that knapsack. In that case, the knapsack is nothing but the bag is contained. That bag, particular bag is contains some weight value, the limitation weight value. If we add some weight, if we add some objects which can have some weight value, means we can't exceed that particular n number of objects exceed that particular bag. This is the knapsack problem. We can't over limit that particular knapsack bag. That is the goal, but we have to store some n number of maximum number of objects in that particular bag without exceeding the limit of that bag. This is the knapsack problem. So this is the one of the example of dynamic programming. Thank you.